Okay, but essentially the question talked about a spherical balloon being filled with helium, and then its surface area is actually increasing at a rate of 8 cm squared per second. Okay, the question is asking how fast is the volume changing when radius is 5. Okay, so since we're talking about a sphere, so naturally we need to know the formula, surface area formula for sphere as well as the volume of a sphere itself. Okay, so let's define some variables first. Let R be the radius. Okay, then A be the area or the surface area. And D be the volume. Okay. So based on the information that we're given, we know that the surface area is increasing at 8 cm squared per second. What this tells us is that dA over dt will be 8 cm squared per second. Okay. What the question is asking for is how fast, that means the rate of change of the volume. So our objective is to find out what is dV over dt. Okay, things that we can know, okay, at the back of our head, okay, or from the back of our head, is that the area, the surface area of a sphere is defined to be 4 pi r squared, and then the volume, okay, of a sphere itself is 4 over 3 pi r cubed. Okay, so we consolidate whatever that we already know first. Okay, then right, from the area and the volume, okay, we see that our area is in terms of r, the radius, and our volume is in terms of r, the radius as well. Okay, there is no way for us to make our volume in terms of a. Okay, because if I want to have one formula that connects our dA over dt and dV over dt, formula meaning this thing that we are looking at, okay, I will need something that talks about volume and area. So for example, if let's say I put dV over dt over here and put my dA over dt over here, okay, what I need is dV over dA. So that so-called, okay, we cancel the dA, we are looking at dV over dt. So this is the formula that we're looking at, okay? But the problem is that how can we find dV over dA, okay? Because our V is in terms of R, our A is in terms of R. So there's no way for us to make our V in terms of R, okay? So we need to have that realization, not possible to make V in terms of R. V in terms of A. Okay, so we need to rethink that this process is not going to be feasible. Okay, but at least we know that when I have A equals to 4 pi r squared, I can find out what is dA over dr, and that is actually 8 pi r. Okay, bring down the 2 and then times 4, so 8 pi. Okay, power minus 1. Likewise with the volume, 4 over 3 pi r cubed, I can figure out what is dV over dr, which is actually going to be 4 pi r squared. Okay, so I can figure out what is dA over dr and dV over dr, right? Just that I cannot have the dV over dA at all. So to rethink the process, okay, perhaps then I can try knowing that dA over dt is equals to dA over dr times dr over dt. Okay, that's something that I can maybe create first, such that I find out what is dr over dt first, okay, and then using dr over dt to create that link towards my dv over dr and dv over dt. Because to find dv over dt, the other alternative to make use of my dv over dr is to then multiply with dr over dt. So this is the connection, okay, from V and A, okay, from V to A itself. Okay, so the A over dt is given to be 8. The A over dr, we found that it is 8 pi r. The r over dt we do not know, but we can solve this equation to find that the r over dt is 1 over pi r. And then dv over dt will be dv over dr, that is 4 pi r squared, times 1 over pi r, which is what we found from the r over dt. And that reduces to 4r. Okay, then now we can find that when r is equals to 5, dv over dt will be equals to 20, and hence we conclude that the volume of the balloon is increasing at 20 cm cubed per second. Okay, so to reiterate, okay, we cannot be using this structure because it's not possible to make V in terms of A. So therefore, we create that link, okay, from A towards our V by making use of the R over dt. Yes, Wayne? Can't hear you. Yeah? Questions? Right? An alternative that Eugene actually proposed, right, was that from A itself, make R the subject, so it will be equals to square root A over 4 pi. Okay, and then putting it into V, if you want to force it V in terms of A, right, it could be done, just that it is algebraically a little bit messy. Okay, so you need to be aware what is it that you are differentiating, okay, and what are the constants. Yeah, it is possible. Okay, however, right, why do I want to still talk about this process itself? Okay, it's also because there might be times whereby maybe the question, okay, segment it into part A, okay, and then part B. Alright, so sometimes maybe they ask you to find the R over dt first, okay, then after that you find out what is dv over dt. Okay, so that is also possible. So I think we need to be familiar with both methods. Okay, questions? Are you all good? Okay, this takes a little bit of time to let it sink in. Okay. We move on to question 10. talks about variables x and y. Right? They gave a very important statement right at the start of the question, telling you that when x is equals to 2, the rate of increase of x with respect to t is 4/5 times the rate of decrease of y with respect to t. Okay? So, first we need to interpret and understand what this section means. It means that we are looking at dx over dt. And then usually when it comes to an English statement, okay, how you can break it into parts is that you can take the cue that is itself means equal sign. Okay, that's how I will always interpret is lah. Okay, so dx over dt equals to 4/5 times. Okay, so we're looking at 4/5 times of something. Okay, that is the rate of decrease of y with respect to t. So rate of y with respect to t, that refers to your dy over dt. And since you're looking at decreasing and down here is increasing, it cannot be both positive. Okay, so this one we take it as negative. Okay, so the statement that we can actually create out of this sentence itself is that when x equals to 2, dx over dt equals to 4/5 times negative dy over dt. Okay, so that is the key thing we must be able to interpret out of the first sentence in the question. Then we're given that y is equals to k square root 12 over x minus x. Okay, let's restructure this to something easier to manage. We can write it as 12x to the power negative 1 minus x to the power of half. Okay, using this y in terms of x, I can find out what is dy over dx. So I bring down the power minus 1, that's negative half. Differentiating the inside, what we will get is going to be negative 12x to the power negative 2 minus 1. Okay, so we have our dy over dx. Okay. Right? So now, okay, we have our dx over dt, dy over dt, and dy over dx for us to actually work with. Okay, maybe let me just reorganize this first into something visually more pleasing. Okay, so this will be 1 over square root 12 over x minus x, negative 12x squared minus 1. Okay. So, in order to draw the connection between dx over dt, dy over dt, and dy over dx, right? Okay, the connection, the formula that we're going to be writing will be dy over dt equals to dy over dx times dx over dt. Okay, whereby we tie in together the dy over dt, dy over dx, and dx over dt. Okay. Then, because we know that dx over dt can be expressed in terms of dy over dt, okay, I'll re-express this as negative 4/5 times of dy over dt. just decided to bring a negative in front for neater writing. Okay. So in other words, we are looking at dy over dt equals to dy over dx times negative 4 over 5. So I can in fact put a bracket here, times dy over dt. So it's all multiplication over here. Okay. What I can do is to actually cancel out my dy over dt, and by cancelling I'm looking at division of dy over dt. So I divide away dy over dt on the left side, I divide dy over dt on the right side. Okay, so since I'm taking this divide itself, that means that I have 1 equals to dy over dx times negative 4 over 5. Okay, so I've gotten rid of the dy over dt in our discussion. Okay, then our dy over dt over here is just times 1. It's the same thing. Okay, so in other words, my dy over dx, I already have this. That will actually be k over 2 times 1 over square root 12 over x minus x. Okay, then after that, times negative 12x squared minus 1 times negative 4 over 5. Okay, my objective is to figure out what is the value of k when x is equals to 2. So I could go ahead and substitute and replace all the x with 2. Okay, so that you get an easier process in calculation. This, you can press in the calculator directly if you want to. Okay, or actually give you 1 over 6 minus 4 negative 12 or 3. So for substitution of x to be 2, this part will get half, this part will get negative 4. Okay. And then we are looking at having 4 over 5 times k. So k equals to 5 over 4. This 1.2. Okay. Alright. So the thing about this question is that you need to create this and then to know how to use this and place it inside the connecting formula, okay, that we are able to create. Questions? Okay, don't bother to go and simplify the dy over dx. That will give you a very big headache. Okay, just keep it like that. Because after all, later on you'll be using x equals to 2 to place it inside to find out the value. Okay? Questions? Alright, shall we look at the last question, question 11. Okay, this is a brief diagram of what the question has given. Okay, they talk about a ladder leaning on the wall, okay, on the corner of a wall. The ladder is 6 meters long. Okay, as it is sliding downwards, this end over here where Q is will actually be coming outwards. Okay, and that is at a rate of 0.6 meter per second. Okay, question wants us to find out what is the rate of sliding downwards when the distance from P to the ground is 4.8 meters. Okay, to help us work with this, okay, in order to generate our dy over dt, dy over dx and all that, okay, let's do some variable definition. Okay, it's really dependent on yourself how you want to define things. Okay, so what I would want to do, okay, is to let the vertical distance from P to the ground dV. Okay, up to you what letter you want to choose. Okay, I just happen to choose V because vertical distance. I'm looking at this one. Okay, so this distance will be V. And then the horizontal distance, I decided to let it be H. So from Q to the wall is actually H. So with that being defined, that means that the 0.6 refers to dH over dt, and that is 0.6. Okay? And then one thing that we must realize is that when our ladder is actually sliding downwards, okay, the ladder doesn't change in its size as it slides. Okay, so the length of the ladder actually remains the same throughout. Okay, it doesn't make sense that as it slides down the shape change. Okay, so therefore this 6 meters is actually fixed. In other words, since this is a right angle triangle, your V square plus H square equals to 6 square, and that is equals to 26. Okay, I can choose to make V in terms of H if I want to, or you can make H in terms of V, that's also fine. So V square equals to 36 minus H square, and V will have to be 36 minus H square. Okay, we should not be considering the negative form of the square root because V is after all a length, okay, a distance, and distances are always positive. Okay. Okay, so after forming out my V in terms of H, I know that I can find out what is dV over dH, and that will be power half bring down, okay, power half minus 1, and then differentiating the inside, you get negative 2H. That simplifies to be negative H over square root 36 minus H squared. So, because I'm trying to find out what is dV over dt, my formula will be created such that it is equals to dV over dH times dH over dt. Okay, and I find that dV over dt will be negative h over square root 36 minus h squared times 0.6. Okay? And since we're looking for dV over dt when h is equals to 4.8 meters, because that's what the question gave, your dV over dt will be equals to this upon substitution. And that's negative negative 0.45. Okay, and we conclude that the top of the ladder is sliding down at a rate of 0.45 meter per second. So because I'm talking about sliding down, okay, I don't need to put in the negative sign. Okay, because the distance V, as this slides down, V is actually reducing. Okay, whereas when H actually, when this point moves outwards, your H is increasing. So that's why this is positive. Okay. So 0.6 is positive, or rather dV over dH over dt is positive, because the ladder is sliding upwards, your H value is actually increasing. Yes. Okay, wait, right. Alternatively, if you don't want to write it this way, okay, you can of course say that the top of the ladder is just sliding. You don't even say the direction. Okay, if you're not confident of the direction, or the question didn't talk about the direction, okay, if the question did not ask for a direction to be specified, you can just say that it's just sliding or moving at the rate of negative 0.45 meter per second. That's actually fine as well. Okay? Yep. Oh, sorry. I'm so sorry. I missed out something very. I missed out something. Yeah. I'm so sorry. This is not H that is 4.8. It is V that is 4.8. Sorry. Answer is still negative 0.45. Okay. Just that V equals to 4.8. H square equals to 36 minus 4.8 square equals to 12.96. H equals to 3.6. Okay, sorry, then dV over dt times 0.6. Okay. Yeah. I'm so sorry. I forgot. I used the wrong 4.8. This one is B, not H. Okay. Questions? Yep. If not, could you submit your homework to the front, please? Okay, pass your homework to the front. Okay, by the way, maybe a quick word about your 10-year series. Okay, no need to rush into doing your 10-year series yet. Okay, I would strongly recommend that you do your topical 10-year series first, rather than to start on your yearly 10-year series. Okay, well, of course the questions are the same. Okay, but I think that yearly 10-year series is only when your topics are already steady. Okay, you're already very good at it. Then you go into doing time practices with your yearly 10-year series. So yearly 10-year series is really more for drilling your time management wise. Okay, topical is really about your content. Okay. Yes. Okay, if you still have any questions not yet done, please just add on to this pile, yeah? Okay. I'll start with, or rather continue with your E-Maths, okay, chapter 3. 15 minutes, 10 minutes.